Hello all, I welcome you on behalf of Edureka for mastering Git and GitHub course. In the last module, you learned the Git lifecycle, worked on basic Git commands, and understood local and remote branches. You also worked with remote repository and performed the Git operations on it. In this module, you will work on branches and merging. Branching and merging are one of the key features, and in this section, you will be learning different ways of merging the branches and how to perform basic Git operation on branches like create, checkout, delete, and so on. You will also create tags and understand the difference between branch and the tag. So these are the objectives. As I said, we will be working on branching in Git, how Git manages branching, how to switch between branches, how to do two-way merge and the three-way merge, the different merging strategy, rebracing, and the Git tags, and also the difference between branching and tagging. So what is branching? Nearly every VCS has some form of branching support. Branching means you diverge from the main line of development and contribute to do work without messing with that main line. In many VCS tools, this is a somewhat expensive process, often requiring you to create a new copy of your source code directory, which can take a long time for large projects. Some people refer to Git's branching model as its killer feature, and it certainly sets Git apart in the VCS community. The way Git branches is incredibly lightweight, making branching operations nearly instantaneous and switching back and forth between branches generally just as fast. Unlike many other VCS, Git encourages workflows that branch and merge, often even multiple times in a day. Understanding and mastering these features gives you a powerful and unique tool, and it can entirely change the way that you develop. So the main another main difference is that developers can create their own branches and can work in parallel. This keeps the main master branch free from the questionable codes. For example, if this one is the master branch, then you can have two more branches working in parallel. One can be the feature and another can be the bug fix. One of the biggest advantages of Git is its branching capabilities. Unlike centralized version control system, Git branches are cheap and easy to merge. This facilitates the feature branch workflow, which is popular with many Git users. The feature branches provide an isolated environment for every change to your code base. And when a developer wants to start working on something, no matter how big or small, they create a new branch. This ensures that the master branch always contains production quality code. Using feature branches is not only more reliable than directly editing production code, but it also provides organizational benefits. So, in this example, we have a master branch, and then in between, we created a test branch and later on created a feature branch. Because branches are lightweight and they are very fast switching back and forth. So, Git branch is essentially an independent line of development. You can take advantage of branching when working on new features or bug fixes because it isolates your work from that of other team members. Branches serve as an abstraction for the edit stage or commit process. You can think of them as a way to request a brand new working directory, staging area, and project history. When you want to add a new feature or fix a bug, no matter how big or how small, you spawn a new branch to encapsulate your changes. This makes it harder for unstable code to get merged into the main code base and gives you the chance to clean up your features history before merging it into the main branch. The default branch name is master. This is created by git init command on the repository. Movable pointer to a snapshot of your changes, and it moves with the changes you commit. So these are the branches operations. We can create a new branch or we can create and switch to the new branch directly. To create a new branch, we have to use git branch and the branch name. And to create and switch the new branch with a single command, we can use git checkout -b and the new branch name. So let's try this. If I'm in module 3 and if I check git branch, then I have three branches: new branch, new temp, and temp. If I create another branch, bug fix, now let's create test. Let's take to bug fix. Then I'm still on master branch. To use the bug fix, I have to choose git checkout bug fix. Now there is a simple way to create and switch to the branch at the same time, and the command is so now what happened is we replaced two commands with the one. So command git branch name, and the second command git checkout branch name is replaced with git checkout minus b branch name. To list branches for a particular repository or to locate repository and click on the branches as highlighted. So we already saw this, but let's go back there again. Let's choose any repository. Let's take the module 3 only. We click on the branch here and then we can see all the branches. We have two branches, remote branches, master and new branch. We can also check that using -a option. So we have two remote branches, master and new branch, and four local branches. Let's discuss the Git storage strategy. So Git does not store data as a series of chain sets or differences, but instead as a series of snapshots. When you make a commit, Git stores a commit object that contains pointer to the snapshot of the content use stage. This object also contains the author's name and email address, the message that you typed, and pointers to the commit or commits that directly came from the commit, its parent or parents. Zero parents for the initial commit, one parent for normal commit, and multiple parents for commit that results from a merge of two or more branches. To visualize this, let's assume that you have a directory containing 3 files and you stage them all and commit. Staging the files usually compute a checksum for each one. It stores that version of file in the Git repository and adds that checksum to the staging area. So after staging, two things are happening. Git computes the checksum and stores the version of each file and adds to the staging area. When you create the commit by running the git commit, git checksum each subdirectory, in this case just the root project directory, and store those 3 objects in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root project tree, so it can recreate the snapshot when needed. Now Git places only 4 types of objects in the object store: the blobs, trees, commits, and tags. We already discussed them in the past module. Now these 4 atomic objects form the foundation of Git's higher level data structures. First, the blobs. Each version of file is represented as a blob. Blob, which is a contradiction of binary large object, is a term that is commonly used in computing to refer to some variable or file that can contain any data and whose internal structure is ignored by the program. For each file, there is one blob, which stores the SHA-1 hash of the file content in it. Next come the trees, which represents one level of directory information, that is, a hierarchical structure which contains information about each of the blob. It creates relationship between directories and the files in it. Next is the commit. The commit object holds the metadata for each change introduced into the repository, including the author, committer, commit date, and the log message. Each commit points to a tree object with all metadata. Next are the tags. So we have not discussed tagging so far, but tagging is generally used to capture a point in history that is used for a marked version release, such as v1.0.1. A tag is like a branch that does not change. Unlike branches, tags after being created have no further history of commits. Now Git supports 2 types of tags, annotated and the lightweight tags, which differ in the amount of accompanying metadata they store. A best practice is to consider annotated tags as public and lightweight tags as private. Annotated tags store extra metadata such as tracker name, email, and date. This is important data for a public release. Lightweight tags are essentially bookmarks to a commit. They are just a name and a pointer to a commit, which is useful for creating quick links to relevant commits. Now this is the storage strategy for object structure. Now if you see, we have at the first level we have blocks where each file is represented as a blob. Next we have tree, which contains content of directories and specifies files stored as blobs. So we have a tree, which tree name, we have a blob, the hash, and the file name. And then we have commit, which is a pointer containing the metadata and pointer to root tree. So this is the commit ID. Then we have tree, which is the tree ID. Then we have author Steve, committer Steve, and the parent JB007. Now on creating a new commit, the new commit will store a pointer to the commit preceding it. For example, this. So this is JB007 and the parent of this commit is this. Now the parent of this commit is this. So this is snapshot A, B, and C. Now, how Git internally manage these branches? Let's say you created a new branch testing using below command, git branch testing. This will create a new pointer to previous commit. The previous commit is this 0BIY2. Now, Git also keeps an additional pointer which is called as head. So head will always point to the last commit of the branch. For example, if the branch we are on branch master, then head will point to this. Now, if we check out a new branch testing, then head will move to the last commit of the test branch. And when we make additional commits in the test branch, the head will move forward, or the pointer will move forward. So there are two types of branches, local branch and a remote branch. Local branch is a branch that only you, that is the local user, can see. It exists only on your local machine. And the command to create is git branch and your branch name. While the remote branch is a branch on a remote location, in most cases, or the default remote name is origin, you can push the newly created local branch to origin. Now other users can track it and can see it. So the default name from local branch that gets created when you run git init is the known as master, which is traditionally it is also known as trunk. So let's quickly do a demo here. Let's go to temp. Let's remove temp and let's go to temp. Oh, mkdir temp. I'm gonna do now git init into it. Now wait, let me first remove it. Now I'm gonna create a file into it. Touch file.txt. Now let's initialize git branch coming. There's some issue with my configuration. Ideally it will show the branch, but if I do get status, I should get I'm on branch master. So this is the default branch I'm getting. Now I can create additional branches such as dev, feature, and bug. These all constitute of branches created for the developer so that they can work parallelly and independently on individual tasks without any interference. Now, certain conventions are provided as best practices. For example, feature branch can be named as feature, bug branch as bug, release branch as release. A remote branch, on the other hand, is a local copy, or the remote tracking branch, I should say, is a local copy of a remote branch. When a branch is pushed to a origin using the command, a remote tracking branch named origin/branch name is created on your machine. This remote tracking branch tracks the remote branch. You can update this remote tracking branch to be in sync with the remote branch using git fetch or git pull. Now let me show you what does the remote tracking branch mean. If I go to module 3, so now this origin/master is my remote branch. I don't have a remote feature branch. Feature is only a local branch. If you see here, this is just a local branch. However, this is a remote branch which has a remote tracking branch origin master. Now let's see the branches example. So when a git clone command is executed, how do we execute the git clone? We just get the copy the remote URL, or we get the remote repository URL, and then we perform the execute the command git clone. Now when we do git clone, then git will pull all data from the remote repository to my local, which is remote repository to the local. Now git automatically names the clone repository to origin. This is the default, and a pointer is created at the master branch, which is known as origin/master. A local master, which is this, is also created at the same position for local operations. Now switching between branches and different commits. To switch to a particular branch, we already know how to clone it, but before we move any further, let's clone it again. So I'm going to remove the module 3. Let's leave the module 3 as it is. Okay, I'm going to leave the module 3 and I'm going to clone it again. So I'm gonna move into the module and let's look at the branch. We have one branch and the one remote tracking branch. So to create a branch, what I can do is I can do get checkout bug, not the checkout, sorry. To switch between a branch, we have to use git checkout branch, but before that, let's create a branch. I can use bug now, and if I do create branch, then I am on branch bug. Now I have created a bug branch. Now there are few other options I can create a branch. So the first one is I can create local branch from the head and can switch to it automatically. So instead of creating git branch, I can use git checkout minus b, let's call it feature. So I have created a new branch and I have switched to it as well. So in general, git branch name, and command, or I should say yes, and command git checkout your branch name is equivalent to git checkout minus b branch name. Now another one is we can create a new branch from the commit hash. So let's look at the commit hash. Now this is the commit hash, so I can use a new branch. And so if I do git branch, I can see that I have a commit hash. If I do git log, then I can see that this branch is the commit hash branch is created from this commit ID. I can also create a branch from for example, for 4 head prior to commit. So the command is same. So if I do git checkout minus b, my branch name, head prior, and then I do head 4. So this will be like, this is the head, then it will go like, first of all, let me go to master. And if I do git log, then I can see that I was on master only. So let's create another minus b new branch. Let's call it head prior and head root 4. So ideally, if I do root 4, then this is like head 1 2 3 4. This should be somewhere around here. So it's switched. So git log. Now if I do git log, then this is the fourth, 1 2 3 4, and this one, as I said. These are all different ways of creating a branch and switching between them. So to switch to a particular commit, we need to use commit hash, and commit hash is this. For example, if I want to switch to this one, I can use git checkout and then the hash. But when we do this, our head will go in a detached state. So we can look around, make experiment, and we can create a new branch using minus b. For example, give checkout minus b and detached. If I do git branch now, you can see this is there. I can do git log and first checkout master. And if I do now git log, I can see that detached is from this commit ID. So commit hash is a generated SHA-1 hash for a particular commit and can't be changed until the user changes the commit details. Now we can also delete a branch. This might become handy. So for example, there might be change scenarios when we spin a new branch, for example feature, we merge it back onto the master so that it goes into production. So feature branch now, for example, has no use and can be discarded as it is already merged in the master. So the way to do it is use the minus d option or minus capital D, which is equal to force option. So if there is unmerged branches, we use minus d. If the merged branches, we use small d. So let's get branch. First of all, see the branches. Then and I do get branch minus d buck. If I do get branch now, this is deleted. Now the point here to note is that this has only deleted the local branch. This is all not deleted the branches into the repository, which is the remote branch. So how do we delete the remote branch? If I do get minus a, branch minus a, we see both the branches. So we have only one branch so far. So let's push one branch on, let's push the bug feature branch on the remote. This will ask for my credentials. So now how can I delete this branch? So I can do like, to delete a branch, I can do git push minus d, the remote name and the branch name. Here remote name is origin and the branch name is feature. This will again ask for credentials. I strongly suggest you to use the passwordless SSH setup in the Git. Now the remote branches Git is been removed, but only removed. And now if you will see, the feature is still accessed because this is on the local branch. Another way to remove that is using git push the remote name colon the branch name. For example, let's push the feature again. We are deleting it, we're not pushing it. So let's remove the minus d and let's push the feature again. To remove it, I can only do add colon here, but before that let's first look at the branches. So I have a feature branch. and to delete it I just add colon before, and it will delete the branch for me. Next comes the merge conflicts. So for a lot of people, merge conflicts are as scary as accidentally formatting the hard drive. A great thing about having Git as your version control system is that it makes merging extremely easy. And in most cases, Git will figure out how to integrate new changes. However, there are a handful of situations where you might have to step in and tell Git what to do. Most notably, this is when changing the same file. Even in this case, Git will most likely be able to figure out on its own, but if two people change the same lines at the same file, or if one person decided to delete it while other person decided to modify it, Git simply cannot know what is correct. Git will then mark the file as having a conflict which you will have to solve before you can continue your work. So in this example, we have this file and these both are modifying the same file and the same line, the third line. So this will create a merge conflict. So merge conflicts can occur on merging branches or when merging forged history together. So merge conflicts are resolved manually by users. Git provides different merge tools to compare and choose the required changes, which we will see in the coming slide, or user can use the third party merge tool with Git. So let's look at the example that this is a file and in the master branch, and we add some line in the master branch again. From the base branch, we create a new branch called feature1 and we add another change in it. So what happens is that when we merge these branch with the master, then we'll get a merge conflict. So let's first create this example. So I'm gonna go again, and now if I look at the branches, now let me remove the old branches which might confuse us, and the head prior as well. Right, if I do the git branch, then I have feature and master. Let's also remove the feature branch. So git branch minus d feature. Now let's edit the test.txt and let's remove it from base branch. Now let's add it to the staging area and commit it. Now let's create a new branch, feature1. Now let's rename it features plain. Now let's edit the test. We are still on the master branch, so I'm gonna use right from master branch. Now same I'll do again. I'll add it and then I'll commit it with comment as master. Now let's check out to switch to the feature branch, change the same file, and let's write from feature branch. Do the same things, add it to stage area and commit it. Now let's go back, switch to the master branch again. Now we already see that there is some point of conflict that will arrive, but let's merge it, the feature branch to master. Now here we get a merge conflict, right? It says that we have a conflict in test.txt and we have to fix it, and then we can commit. So there are many ways available, but the one quick way will be that we use some tool. So what we're going to do, we are introduce some tool which is using kdiff tree, and the command is git config. We said we already discussed git conflicts in the past module as well. So if you have any issues in them, or if you are not sure what they are, I request you to go back to the previous module and just brush this up. So we are setting a global config where I'm defining merge tool as kdiff tree. Now once that is done, we just run this command git merge tool, and this will open us file, and then we can select which merge we want to see and which not. So here what we get is we get the total number of conflicts 1, number of automatic to solve conflicts 0, number of unsolved conflicts 1. So we have the base branch, we have the local branch and the remote branch. Remote branch is feature, local is master since we are on master, and the base is the parent branch. Now we saw the base version. This column as displayed here represent the changes which will be made in this area. So we can go to the click on the letters, and then it will enable us to see what we want to keep. For example, if I click on B, if I click on A, then no source line. If I click on B, because there is no source line in the master, hence we're getting this. We are not updated, we added a line. If I click on B, then I get from master branch. If I get C, then I get both. If I remove B, then I can keep only feature. So let's keep the both. and let's save this file. Right now, once that is done, I can open my test.txt and look at this. I can now commit it again. Let's look at the Git status. I can commit it. Also have a look at this file. So this is how it will resolve the conflict in case there is no tool we are using. So this line has no conflict from base branch, hence it is above. Then we have conflicts in the second line. So where what he is saying there, that for the branch head branch which is pointing to master, this is the line from master, and then we have the separator line, and then we have the line from the feature branch which we are trying to merge from feature branch. So we can do it manually. How? We can delete these lines, and I can decide that I want to keep them both, so I just do keep them both. So let's now discuss about stashing. First of all, let's look at the requirements that why stashing came into picture. So often when you have been working on part of your projects, things might be in a messy state and you might want to switch branches for a bit to work on something else. The problem is you don't want to do a commit of half done work just so you can get back to this point later. The answer to this issue is the git stash command. Stashing takes the dirty state of your working directory, that is your modified untracked files and stash changes, and saves it on a stack of unfinished changes that you can reapply at any time. Please note, it does not consider the untracked files. Stash the changes in dirty working directory. By dirty we mean the work that is not completed yet and is in progress. Stashing command only takes the uncommitted changes. They might be in the staged area or they might be in the unstaged area, but they are track files. So stash command flow is, it records the current state of working directory and index. It saves local uncommitted changes separately and reverts the working directory to head commit. After this, you will get a clean branch. Once that is done, you can reapply the stash changes again when you come to that branch using stash pop or stash apply command. And in case you don't want to apply any stash changes further, you can just clear the stash. So these are the changes for stash. For stash to local changes, by local we mean the local branch, we use the git stash command. To list the modifications stashed away by this command, we can use the git stash list, and to inspect or check the details we use git show stash. So let's look at this. So we are going to continue using the module 3 project. So let's do git status. So we have this untracked file, and now I'm going to change the test.txt. Now I'm going to remove all this and say this is for stashing demo. Now if I do git status, I can see that test.txt is modified. At the same time, let's also change some of the file. Let's change the readme.md. This is for stashing. I'm gonna put this readme.md to the staging area now. So if I look the status, we have one in the staging area, one is in unstaged area, and the last one is in untracked file. If I look at the git branch, so I have feature branch and master branch, and we are currently on feature. If we, for example, let's first try to check out the feature branch. There's a typo in my command. So it is not allowing me to do a checkout of feature branch. Why? Because I have changes in the staging area, and it is asking me to commit my changes or stash them before I switch the branch. So if I look at the branches again, maybe I'm still on master, and now I'm going to do git stash. So I can now go ahead and change the branch, and if I look the git status, then I only see the untracked files, while the files which were unstaged area or which were in the staged area are not present. Let me revert back to the master branch. Now let's list the stash changes. We have one stash, which is this. Let's also show the changes in it. So here is that we have a commit ID. This is the commit ID and the merge, the author name, date, and some other comments. And now I can see the changes. So I have two files. One is the test.txt, when I have removed these three files. And if I do the status, then let me pop git dash pop. So I have two modified files, readme.md. Now the point here is that the files which are in the staged area, for example readme.md was in staged area, they now have been moved to the unstaged area when I do stash. So this is the git status. Now I can apply them directly. Now I have to do git stash. First of all, let's look at the list. No, so let's stash this again, and now let's do git stash apply. So once I do apply, I get the same thing. If I do the git status now this is the demo that we just saw. Now at the same time, I can use the git stash clear command as well. So let's look at the different options that we have in the git stash. So we have list, show, drop, pop, apply, branch, clear, create, store. We can use these different options. For example, list that we currently saw, we also looked at the show, pop, apply. I can create a branch as well, starting from the commit at which the stash was originally created. I can remove all the stash entries using clear. I can remove a single stash entry from the list of stash entry. I can create a stash entry, and I can store the stash created via git stash create. These are some examples as well, so you can check them in your workspace. So what we're doing here is, if we do the git status, we can see that we have two files in the unstaged area, the readme.md and the pom.xml. After stashing the changes, no changes are left in the branch, and git status command shows that the branch is up to date. Now what we did is, if we do the list, then we already saw this. When we did the git show, then we see the difference. There is readme.md and there is pom.xml. Same as the case that we saw. If we go back here, right, so we have test.txt. I don't know why we are not seeing the readme.md. Maybe that was because it was in the unstaged area. But if I do the git status now, and if I remove this test.txt.orange, and if I do git stash now, then let's do the git status. So it is up to date. If I do git stash show stash, then now I see the readme.md. It was not displaying the readme.md because it was in the staged area and moved to the unstaged one. We can apply the git stash using git stash apply. But if we look at the status, so far it is up to date. But if I do git stash apply, then we have moved these files in the unstaged area. We can also use the git pop, the same that we already saw. Now let's look at the two-way and the three-way merge scenarios. So let's first discuss the two-way merge scenarios. So to understand this, let's take a scenario where we have two developers working on the same file. File has these three lines. They both checked out the file and made some changes to it. So they both have the same file, and they are modifying it on their local repository, or the local copy of the repository. So the first developer removed the first line, and the second developer added a line at the end, GHI. Now second developer commits his file, which is this, and now the first developer needs to merge the second developer's changes into his copy, which is happening here. In two-way merge, the tool will compare the two files and will try to identify the first, and not just tries, and it identifies that the first and the last lines are different, because here's ABC, here's blank, and here is GHI, and here there is no line. But it does not know that what to do with the differences, or which line should be included. Now in three-way merge with git follows, we can clearly see that the first developer, or the git can clearly see that the first developer removed the first line and second developer added the last line, because git not only compares the two change files, but it also compares them against the original copy. Now using this information, git creates the merged version. So this is the merged version. The last line has been added, but the first line remains in conflict. So this is the default strategy used by git while doing the merge operation. Git offers various strategies that we can cover, or we can choose for three-way merge. So let's take this scenario. We have a feature branch. So what I'm going to do is, I'm going to git checkout. Now let's do the git status again. So let's modify the test.txt as per the changes. We have ABC, DEF. Now let's remove the branch feature, and let's create this branch again and then switch to this branch. If I look at the test.txt now, then the first, we only remove this line, and let's commit it. Now let's switch to master now, and let's modify test.txt again. Oops, there seems to be some issue. Let me modify, let me do the git status first of all. Right, let me remove this. So this is the default version. I'm going to commit this as the base branch. Now let's remove the feature branch and recreate it. Now let's do it using different way. We have to forcefully delete it, which we did. Now if I do the git branch, then I see only master. If I do git status, git log to verify, yes. So let's also do the cat test.txt and we get the same result. Now let's create and switch to the new branch feature. Let's go open the test.txt. Let's change it. If I do git status now, then I have file and test.txt. Commit from second developer. Now let's do the git checkout master. So if I look at the test.txt now, then this is the default merging strategy that happened. It retained the blank line and removed the ABC, and it retained the last line. So this has been done automatically. If I look at the merge option, then auto merging, merge made by the recursive strategy. So these we are going to discuss this strategy in the coming slides. And this is the test.txt wherein it has added and removed lines. So one fine change, one insertion, and one deletion happened. So let's discuss these merging strategies now. So far, if we see here, we have the merge that we have seen here has been done using the recursive strategy. So merge strategy defines the internal algorithm which will resolve your merge when using the merge command. So merge will happen between two or more branches. We know how to do a merge. We also saw that the finding the difference between the merge and how to resolve the merge manually in the Git. Not the merge, but I should say the merge conflict. So there are various merge strategy that can be used based on different needs. There is a resolve, there is recursive, which we currently use. There is Octopus, Hours, Subtree, etc. Some of the Git merge strategy have further options which can be passed using X flag. And to select the merge strategy while git pull or git merge, we use the /-s option. So if you go to git merge help, then let's go to, yes, this is the strategy we are talking about. For you, we use the given merge strategy can be supplied more than once to specify them in the order that should be tried. If there is no dash sign, a built-in list of strategies used instead. So first one, let's discuss the resolve. Resolve strategy resolves the two different heads, that is the branch and the branch from which you pulled the code. It uses a three-way merge algorithm. So since Git uses a three-way merge algorithm, this is safe and fast, and it detects the conflicts between two branches and resolves it. This is why it is called as resolve. But there are two heads involved. One, your branch, and the branch from which you pulled the code. The second one is the recursive that we currently use. So it resolves two heads using three-way merge algorithm. As I said, Git uses the three-way, hence it is there. In scenario where multiple common ancestors exist, like here, it merges the common ancestor and uses that as a reference. For example, in our example, the master feature was created from the master. So this is the master, and this is the common ancestor. This is the base branch, and the master then moves forward, and the feature branch also moves forward. There are lesser merge conflict when using this strategy, which we currently saw. This has the ability to merge involving rename. So this is the default strategy when pulling or merging one branch. The second one is the octopus, or the third one is octopus, I should say. So it resolves cases with more than two heads. So we have three heads here. It does not work with complex merging, wherein the manual conflict resolution might be required. This is used to merge three or more branches into other branch. For example, we have three branches and they are merged into one single branch. This is the default merge strategy when pulling data from multiple branches. Another one, the merge strategy is hours. So this resolves the number of heads together. It forces the conflicting branch to be auto-resolved cleanly by favoring the hour version, and all changes from other branches are ignored. It supersedes all old changes of side branches, which is the other branch. This is preferred when resolving multiple heads, and our version of the head is preferred. For example, I have this master branch and I prefer the master branch version, then I should use the hours resolving strategy. Next is the subtree strategy. So this is the modified recursive strategy. We already saw what is recursive, wherein which is here. This is wherein it is we have a common ancestor, and this is the default strategy that is used when we are pulling or merging branches. While in subtree, we use it when we want to include the content of other independent repository into our working repository. For example, we have two repositories and the first one is independent and we want to include into a working repository. So Q is first adjusted to match the structure of P. Now this is the example we have. For example, a repository 1 which is a local repo, and we have repository 2 which is again a remote repo, and these two are merged together. So Q, if we consider Q, is fitted to adjust the is first adjusted to match the tree structure of P. Now this adjustment is made for common ancestor tree, and it enables managing one repo inside other as a subdirectory. The next is the fast forward merge. So this is used when linear path is present. For example, here we do not have multiple paths, but there is one linear path. So rather than merging, Git will just move current branch step to the target. For example, the master branch is created from the master and there has been no new development in the master. Then if you use this strategy, then the current head or the head of the branch will move to the head of the feature branch. Let's look at merging and rebasing. So what is rebasing? Rebasing is generally used to incorporate changes from one branch to the other. For example, if I have two branches and we want to create another branch from it. So let's say that a developer who is on master branch got diverted and made some commit on two different branches. Now by default, Git merge prefers a three-way merge because this is what the strategy the Git uses, and the following things will be performed to merge these branches. So merge will happen between two latest branch snapshot, for example the feature and the master, and the most recent common ancestor of the two, which is commit 4 and 5 is commit 2. So 2, 3, 4, 5. This creates a new snapshot and commits it, which is this. Now another way to achieve the same in the previous slide is we take the changes in commit 4 snapshot as a patch and apply them on top of commit 3. This is called as rebasing. So here what we did is we experimented and we merged the two branches together into another one, which is commit 5. Here we are not merging them, but we are taking the patch changes in the patch and we are applying them on top of the commit tree. This will move us to commit 5. This is called as rebasing in Git. Now in order to perform rebasing on the feature branch, we can use Git checkout feature. We switch our branch and then we rebase on the master branch. So if I go here, so what will happen is that I'll check out the feature branch and then I do Git rebase master. Let's take this example that we have the commit 2, which is the base. If I do Git checkout master and if I do git log merge branch feature, this is what will happen. So let's move to this commit. Let's not move to this commit, let's modify the file. Okay, let's take the same branch but just remove feature branch. Now we switch to new branch feature. I can go ahead and modify the text.txt. So this is, let's add the EVC here. So this is my commit. As for the file, this is now my commit 4. Right now I do master and I modify the test.txt and I say, and I do git add same thing commit 5. It was supposed to be commit 2, but that's okay. Now what I have to do is I have to actually perform the rebase. So I'll go to feature and I'll do git rebase master. Now if I see the test.txt, then this is what I get. I get ABC, which was already there, and I get the HIG as well. If I look at the git status now, then we have no untracked files now except this hash file, which is a temporary file. Now I go to git log and I can see that we are good here. Let's also look at the git branch here on feature. Let's go to git checkout master. Now you see that I have applied the changes onto the feature branch. Now what I did is I took the commit changes and applied it on the branch. So how rebasing actually worked is that it navigated the common ancestor, which is commit 2, and calculate the difference between each commit and save those to temporary file. Next, it reset the current branch to the one that we are rebasing, which is master, and then it applied each change in turn. So if I see go to the feature branch on which I did the rebasing, then I can see it in test.txt, because I've only added the ABC here, but the HIG has been added from the master. I have only applied HIG here, but in the previous I have applied the. So there are certain advantages of rebasing. Number one, it creates a cleaner history than merge. Because if you go here, then my history is clear, right? There's no merge history there when complicated changes are made. This way, we are avoiding the merge conflicts. We don't got any message of conflict in our example. The merging uses endpoints to merge, while rebasing just replace the changes from line to line in the order of changes. That is why the merge conflicts does not happen. Mostly used by contributors who are not maintaining the project. For example, when we are suggesting a change, we are not maintaining it, but we are just suggesting it. So someone might take a patch of it and apply. Now let's look at the difference between merging and rebasing, because they are both doing the same thing, right? Merging, first of all, does not provide clean history, but it includes all merge commits, which we can see in the Git log. However, rebasing, it provides a clean linear history when working with multiple branches. Merging preserves the complete history of projects, including rewriting of public commits. It does not preserve the complete history. So we use rebase when we want clear picture of commits for easy tracking, and also when I don't want anyone else to see the unnecessary public commits and merges. While merge should be used in case when everything on the branch, such as public commits, are required in the history. Now let's understand the Git tag. We have been putting this on the back burner for long. So let's look at what the tags are. So tags are specific points in the history which are important. For example, a certain release or certain version or certain bug fix. So tags are used to mark the specific important milestones. So there are two types of tags. One is the lightweight tag and the second is the annotated tag. So generally tag is like a branch that does not change, and unlike branches, tags after being created have no further history of commits. Now these two types of tag, annotated and lightweight tags, differ in the amount of accompanying metadata that they store. So the best practice is to consider annotated tags as public because they include the metadata, and the lightweight tags as private because they have no metadata. Metadata, when I talk about, is generally the tagger name, email, and date. This which is important for public release. So they are stored as full objects in Git database. They point to tag object in the object database. Checksum contains the tagger name, email, and date, which is annotated, and they have a tagging message which is used to keep all information. So this is the example for annotated. This is the example for lightweight. So lightweight is simple git tag name, and I get the tags. This is if I just type the git tag, I'll list all the tags. While the second one is annotated, wherein I specify git tag minus a, my tag name, minus m, my message, right? And if I go here and type this git tag, list all the tags, then I can see them. Now git tag will list all the tag. Git tag minus l allows me to filter it based on the pattern. Or I can, once I have the tag name, I can do git show tag name. So let's go ahead and create tags. Let me first see the branch I'm on. So we are on feature branch. Okay, let's do git tag and then v1.0. Now if I list the tag, this is what I get. Git show, I hope this is the command, git show directly. So this is the tag I'm seeing. We are on commit 5 and displays the what did happen in the commit 5. Now let's also create the annotated tag. So git tag minus a, my tag name, and minus m, my message. v1.1 and my message sample annotated tag. Right, if I do now git tag, then I have two tags. If I do git show 1.1, then I get the tagger name, which I am not getting in the lightweight tag. I get the date and I get the message, and then everything else is same as in the lightweight tag. Now this, whatever happened so far, has happened on the local, because if we go to the GitHub, so let's go to our GitHub. So if I go to GitHub, I can see that I don't have any tag. I have only one branch master. So I can always push the branch, but the important point is there's no tag so far. And I'll have to push it to the remote. So how do we push it? The same way we push the branches. We do git push origin and the tag name. So let's push the tag to the repository. And we use the same command. We use git push origin v1.0. v1.0 is my tag name. Okay, if we go here and if I refresh this page, then my tag is here. So this is the tag that I'm currently on. This is tag v1.0. To push all the tags in the system to remote repository, we can use dash dash tags. Let's try this command. Rather than pushing an individual tag, we use dash dash tag. I can also check out a tag, but as I said earlier, as we see earlier with the hash commit, checking out the commit ID, this will put the head in the detached head state. So I can create a new branch by using the branch. So let's check out 1.0. What it says is that we are now in a detached head state, and we can look around, make experimental changes and commit them. So if I want to create a new branch to retain commits, we have to do this git. Let's first look at the status. Head is detached at v1.0. So let's create a new branch, retag underscore v1.0. Right, if I do the branch, then we have a new branch available. I can also delete a tag from the local, and the command is same just like it is with branches, that I do git tag minus d v1.0. Right, if I do now git tag, if I list all the tags, then there is only one tag. Now to push it to the origin, I have to push it to the origin as well. I mean delete it to the remote repository as well. I can use git push origin 1.0. Now if I look at the tags here, then I have only one tag. I can also use the minus delete option as well. These both are same. So now we know what is tagging. Let's look at the difference between branching and tagging. So tagging refers to the version of a particular branch at a particular point of time, while branching refers to creation of an independent line of development. So tagging is for our reference purpose, wherein I'm adding a bookmark, while branching means creating an independent line of development. Now changes in tags are not recommended. It is to tag a milestone while development is in progress, right? While merging is used to merge other branches with the main branch, for example, or when using a particular Git workflow. For example, if I'm using features, for example, if every feature is getting developed in a new branch, then I will very frequently use the Git merge to merge that to the main branch, maybe a development branch or maybe a master branch. So in this module, we looked at what is branches, we looked at type of branches, what is stashing. We also looked at the three-way merge, the merging strategies, and we looked at the tags, which are again a gateway to milestone as we progress our development. Thank you.